All right, well, we seem to have a really good turnout, so we may as well get started. So, hello everyone, thanks for joining us. This is a celebration of National Science Week, as I'm sure you're aware. And in particular, what we're here to do is to have a question and answer session around AuScope's contribution to National Science Week, which this year is this online immersive Earth science experience, which we've put together. If you haven't had a look at it yet, then please do have a look. I think Joe's going to stick a link into the chat. So please have a look through the website over the next hour while we present the Q&A. And obviously, if you have any questions or comments, then we would gratefully receive them. So my name's Tim Rawling. I'm the CEO of AuScope, which is Australia's Commonwealth supported provider of research infrastructure, which is tools and technology and talent. And we support the Earth and Geoscience, Earth and Geospatial Science research sector primarily, who are working to address national challenges and questions in geoscience. And what we're presenting here today is a collaborative art science project, which is really something new for us. So AuScope and the team at AuScope has worked with Professor Graham Hindson, who's obviously on the Q&A, and his team from the University of Adelaide. And we want to share an experience of imaging the Earth in a remote part of the Australian continent in Wiljali and Danggali Country. As I said, my name's Tim Rawling. I'm the CEO of AuScope, and I'd like to take this opportunity to acknowledge the Wiljali, Danggali and Wurundjeri people as the traditional custodians of the land on which this creative storytelling project has been imagined and realised. I'd like to pay my respects to their elders, past and present, and to acknowledge their deep and continuing connection to the places where we work, including their traditional knowledge of the geoscience and earth processes over tens of thousands of years. So for this project today and in this Q&A, I'm joined by the creator of the project, Graham Hindson. And Graham, I'll get you to wave so people know who you are. There he is. I hope you can all see the people that are pinned across the top. And also two of the creatives from AuScope who really put an enormous amount of work into this project. So Joe Condon, who's there, and Philomena Manifold. And we're also delighted to be joined by an emerging Earth scientist, Erin Tuahino. And Erin's waving there. So we've got an hour together today, and we really want to invite questions about this project by getting them to post them into the chat area of this Zoom session. And we'll come to all of the questions that we receive later on. And if we don't get time to deal with all of them, we'll certainly respond to you all individually. So please put any questions you have into the chat. But to kick things off, I'm going to start asking our panelists a few questions that spring to mind for me and to try to get the conversation started. So I would like to help paint a picture of what this project's about and why we're excited to share it with you. I should also mention that the session's being recorded. So if you'd prefer not to feature in it, please turn your video off or your sound off so that you don't get recorded. So my first question is to you, Graham. And I really just want to ask, what is the Curnamona Cube and how is it different from previous data collection projects that AuScope and your team have been involved in?
Okay, thanks very much, Tim, and lovely to be part of this Q&A session today. Welcome, everyone. What I'm going to do is share my screen now and just put a background image that I can let run. So hopefully you can all see now a view of the Curnamona region. So let me give you the big picture. So we pitched this idea to AuScope a few years ago now to say, the Curnamona province, which is an area that straddles between the Flinders Ranges in the west, and in this view you can see on the map the sort of greener brown regions. They're the topographic highs. So that's the Flinders Ranges down the western side. So this is a plan view or a map view. And then to the east we've got what's called the Barrier Ranges, and in the south sort of eastern part the city of Broken Hill. And this region comprises the Curnamona province, which is shown by the black outline here. And it's approximately, if you take the whole region from south to north and west to east, it's about 400 by 400 kilometers. So it's an old Proterozoic part of the continent, means it's a very old part of the continent. It has a 2 billion year old history. And the pitch we put to AuScope was, could we surround it with instrumentation, and particularly seismic and electromagnetic instrumentation in a method we call magnetotellurics? And could we put a grid of instruments over the top and combine that with all the other geophysical data sets to really produce a three-dimensional or a cube model of the Earth underneath the Curnamona province, in this case to a depth of about 400 kilometers. So we've got lateral and vertical dimensions of 400 kilometers or so. So we've been working on this project now for a couple of years, and we've been collecting both the seismic and the MT data. And I'm just going to run this background image through, and this is one instance of the kind of outputs we might get from a project like this. And this is the deliverables and the outputs we give to the geoscience community. So I'm rotating around the cube. It's like a dice in your hand, and you're looking at different faces and slicing it through and slicing it back. And this is colored by a property called electrical resistivity. So we're seeing from the surface, and this is one view from one side down to 400 kilometers, and I'm rotating it backwards and forwards and roundabout. And you can get a sense of how the Earth changes. And so we're capturing something about the deep Earth, but also what we see now is a sort of a collection of everything that's happened over the last 2 billion years. And the Curnamona is a very important part of Australia because it's really at the boundary between the western part of Australia, which is very old, Proterozoic and older, and the eastern part of Australia, which is newer, Phanerozoic and younger. And so the Curnamona really sits at the edge of these two, and so has a very pivotal role on how the Australian continent was put together. So if we understand something of the Curnamona, we understand something about the deep Earth, and we understand something of the deep time, and that gives us a sort of fresh insights into the geology and the tectonic evolution. So Tim asked also about how this project is different from what we've done before, and to a large extent, a lot of the AuScope facility is involved in building and developing new equipment and deploying those equipment out for teams around Australia and internationally to collect world-class data sets. The pitch for this particular project was to consider focusing on one area to produce a major product which can be used by many different parts of the geoscience community. So we were trying to really in view and like a telescope into the Earth, what the Earth looks like, and then really trying to understand its different physical properties from the surface down to 400 kilometers or so, and then understand how they represent changes in the Earth over time. So the video is almost run. What I'm showing at the moment is what we call isosurfaces, so different boundaries in the electrical resistivity. And you can see that if you highlight certain places and certain ranges and color ranges here, you can pick out different things about the Earth underneath the Flinders and the Curnamona province. So I think I'm going to stop that video now. It goes on for another minute, and you can find this video amongst some of the other aspects of the project on the page that Joe has promoted. So I'll pause there and return back to our main screen. So thanks, Tim.
Thanks very much, Graham. That's really fascinating, and obviously this is an incredibly valuable data set for the geoscience community and for people who are trying to understand the evolution of the Australian continent and have some really big science questions that could relate from anything to how resources were deposited within that region to how it responds to different aspects of human activity. But putting the science aside for a minute, when you proposed this project to us right at the start, you were really keen for us to have a science communication component to the project, and in particular, an artistic component to that. And that's really what this website that we're kind of launching today is about. So would you care to comment on that and why you saw that as such an important part of the project?
Yeah, thanks, Tim. Yes, these are really interesting questions because, as scientists, we have a very precise language. We describe the world in certain ways. And as a geophysicist, I'm even more restricted in talking about properties such as electrical resistivity and elastic variations and seismic velocities and perhaps magnetism and density and so on. And many of these are they're physical properties and we can measure them in the lab, but to people outside of our fields, they sound quite abstract and quite difficult to relate to things we experience in our everyday lives. So in producing outputs from this Curnamona project, we were aware that we could certainly produce the big scientific outputs. We can produce data sets, we can produce models, we can characterize things in certain physical ways. But our community that we engage with is relatively small. We're a small group within Australia and internationally. So the language we talk about and the types of activity we talk about are very restricted in the way that people can understand something of what they actually mean and what they can produce. And I think in particular, the concepts of deep Earth, so looking down hundreds of kilometers into the Earth and having something useful to understand in those hundreds of kilometers, but probably even more so in deep time, because we get used to the idea of talking about millions and billions of years. But to everybody else in our community, 1 billion years is an incomprehensible timescale. So the fact this part of the Earth was in a completely different, perhaps, hemisphere connected to different bits of continent, has been shuffled around the world over billions of years, is a very, very difficult concept for not just everybody, but even the geoscientists. That's quite something that takes a while to understand and get your head into. So thinking about the project, we were thinking about trying to describe the project with a different voice, to talk about not just purely the science, but in terms of perhaps the people involved in the science, because all the science involves people, collection of data, interaction with communities. It involves interacting with our natural world. It involves technology. It involves a whole range of different aspects that actually we don't capture in a typical scientific project. So we were delighted to engage and work with AuScope and with Joe and Philomena and the team from the University of Adelaide to try and sort of change the dialogue a little bit and change the way we describe the experiment, so that not only was it about the science, but it was also about how we did the science and what we did in the science and who was involved and what are the implications. So I think you'll see from the website that we've presented this in a very non-linear and non-traditional storytelling way. So a typical science paper would have a typical formula of the way you write the paper. And what we tried to do is to sort of break that down a little bit and describe the world in a different way. So thanks, Tim, back to you.
Thanks very much, Graham. Yeah, and look, from my point of view, this was a really exciting opportunity. And, you know, I'm very proud of the communications that AuScope puts out, and that's down to our team of Joe and Philomena largely. But this was like a really unique opportunity for us, I guess. And I think we've got a very progressive communications team. But a question for you, Joe, you know, this was something that we'd never really tried before, and it was something really new. So how did you and Philomena respond to this request, and what was the process like for you?
Thank you, Tim, and welcome everybody. It's great to have you here today. I think the best way to explain how we responded is instantaneously to Graham's email when he reached out to us a few months ago to say, would you like to do some kind of a science communication project as a side project to this science project? And we jumped at it. I responded within 3 minutes, I reckon, Graham, but it's probably the fastest email I've ever responded to. So yeah, we had some discussions over the recent months leading up until July, when one part of this deployment occurred. And in mid-July, we had a week where we thought, okay, we're really close to going, we're about to book flights, and then all of a sudden we did, and within that week we found ourselves, Philomena and I found ourselves flying to Adelaide, driving up to Broken Hill with the field team, spending a day in the field with the team, and then flying back via Mildura to Melbourne and taking a breath. We had a whole bunch of gear with us, cameras, 3D cameras, microphones. We were kind of buzzing around the science deployment mission when we were in the field, having a good old time collecting whatever we could and kind of listening to these aspects of the science. Thanks to Graham for all the explanations and everybody else in the team. But yeah, all of these kind of side narratives that came together. And I think Philomena and I went into it with an open mind, thinking, gosh, we really don't know what creative direction we might take in responding to this field experience. But when we got back, it became quite apparent that we felt very connected to the sort of exploratory mindset of a science project like this, or any science project. It's the discovery, it's moving into the unknown. And Philomena and I really wanted to share that sense of discovery with Australian audiences for Science Week. So we were also very inspired by the very classic science posters that you might see in the university hallways, where you've got hand-drawn illustrations of minerals filling up a poster spread out all across, and you see the breadth of the specimens that the Earth produces. So that's why you can see this web experience looking kind of similar to that in the sense of an illustrative style, thanks to Philomena's amazing illustrations and some cutouts. I'll just share the experience with you now, just in case you haven't seen it already. Bear with me. Okay, so basically, I won't spend too much time here, but I just show you the homepage. This is basically all of the objects that you can click on and step through to learn something about the project, whether it's a science fact or a really detailed explanation, some extra resources to link through to, or whether it's just a hilarious aspect of being in the field, such as what did we do? Some radio jokes, for example. I think I really enjoy the radio jokes page, which is this one here. So we've got 360 here and opportunities to meet all of the team. On another page, here's some interviews with people that we're able to take in the car on the way to different sites. And then the serious stuff, like what's this project about, like Graham explained, and why are we doing this? Which is very important as well. So there's a lot of material for you to explore over time. This will persist into the future. And yeah, I think that's kind of the essence of how Philomena and I responded creatively. Thanks, Philomena, for being a great partner in crime in the field. Thanks to the field team.
Thanks, Jo. Yeah, and please do check it out if you haven't had a chance to yet. It is really a very immersive page with soundscapes and all sorts of material that you can really dive into. And I'd remind you that this is a Q&A session, so please, if you do have any questions, put them in the chat now, because we will get to all of your questions in a couple of minutes. But I guess hearing Jo talk about this makes me want to ask Philomena a question. And for those of you that don't know, Philomena's got some sort of skin in this game. She's the author of an amazing book about the geology of the Great Ocean Road called Written in Stone. So I recommend you check that one out as well. But Philomena, I guess this was a different sort of challenge for you. So what sort of challenges and opportunities did you encounter doing this science comms project?
Thanks, Tim, and hi to everyone out there. I can see all your names. I can't see anyone's faces, but I'm trusting you're all there. So yeah, the challenges are, oh, there you go, there's a face. The challenges really came down to time. I think it was quite a limited amount of time that we had, especially out in the field. Like there's so many unknowns when you do a creative project. And when you only have really one day to gather everything, you kind of have to really bring all the tools and hope the weather's okay and just get the material that you can. And so we brought, you know, as Joe mentioned, cameras and audio equipment. I brought watercolors, but I definitely did not have any time to do any watercolors. So it was more about fitting in with the kind of field plan of the day with the team. And so we were able to get photographs and like little moments for interviews, and it was kind of limited by that, but then it also meant that it was quite spontaneous and we got some really great moments as well. So there were opportunities, I guess, in that. And another challenge was for me learning new skills. I learned how to use a 360 Instagram camera, and it has a selfie stick, which I thought I'd ever find myself on the end of. But it actually captured really amazing immersive material, which I think was a really big part of what we were trying to do with this project, which was giving the general public experience of what it's like to be a scientist out in the field doing good like science. And so we caught a bit of the 360. I think my skills can improve for the future, but that was really, really fun. And yeah, I really recommend checking that out. And then as an overall opportunity, I feel like as a science communicator, I'm often talking about impact and outcomes and communicating that, but there's this whole other side of science, which is the work that goes behind those big outcomes. And I think the general public are really curious to know how we come up with these discoveries, and what is it really like to be out in the field and making discoveries, and the kind of human experience of that, the wonder and the fun and the adventure of it. And I thought this being able to go out in the field and document the team doing their work was just really exciting, and it's kind of new in a way, like science as it happens. So that felt really good. And I just know that as a geologist, when I was studying, field trips were everything. And when I often speak to other students or geologists, everyone kind of almost without an exception mentions fieldwork as one of the big things that got them into geology and got them into science. And I think giving the general public a kind of experience of that will just give maybe more opportunity for future geoscientists and just everyone to get into the work that we're doing. Yeah.
Fantastic. Thank you very much. And what a perfect segue for me to ask a question of Erin. So Erin, you know, you were on this field trip as a student, and you were working with this sort of diverse group of scientists, but also creatives. And, you know, I'm just interested in your thoughts and how it influenced you and your experience of the field trip.
Yeah, thanks, Tim, and thanks for having me today. I mean, the whole experience was great, but particularly meeting Joe and Min and sort of seeing what they do was really interesting and a really fun experience. Also, you know, seeing the final product and being a part of this today. One thing that came up in one of my subjects only last semester is that there's actually a lot of creativity in science, you know, thinking of sort of the next big questions, or new ways to sort of ask those questions and answer the questions, or new ways to present data and sort of new ways to visualize them, takes a bit of a creative mind. So that was really rewarding. Sort of, I really took that on board, because I have a bit of a creative side that I didn't think would be necessary, or maybe not even sort of, it wouldn't be satisfied in a career in science. So it was really sort of heartening to know that. But then sort of to see this side of things and see what else can be done, and see this merger between arts and science has been really interesting, and it's given me a lot to think about and a lot to sort of explore. You know, I don't know where I'll end up. I'm still working that out. But no, it's certainly given me something to consider.
Fantastic. Thank you, Erin. So I can see that we've got a few questions coming through from the from the floor, from the community. So Joe, I might throw over to you and see if you can throw some of them at the panel.
Yes, certainly. We have one question, first of all, from Vivek, whose mind is sufficiently blown. Thank you, Vivek. A question on critical minerals exploration as I work in the clean energy space, particularly government policy. How do we currently know whether there are enough of these critical resources within Australia to be manufacturing our own clean energy technologies, for example, batteries, solar and wind turbines? Maybe that's for you, Tim.
What a great question. Thanks, Vivek. Look, we know that the demand for critical minerals is just growing exponentially because we're trying to move away from a carbon-based economy. And to do that, we need to be able to generate clean electricity and we need to be able to store it. So the requirements for battery technology are just growing exponentially. The move to electric vehicles requires an enormous amount more of these critical minerals and including copper. So we consider copper to be a critical mineral. And when you think about an electric bus requiring 20 times as much copper as a normal bus and an electric vehicle requiring 4 times as much copper as a normal vehicle, you realize that the demands are going to be enormous over the next few decades. In fact, we've seen some modeling that sort of predicts that we're going to need to find the largest copper deposit in the world is Escondida. And we're going to need to find 8 more of them in the next 10 years to supply just the demand around copper. And the story is the same around lithium and all of these other critical minerals. So the challenge in Australia is we know that we have an enormous number of critical mineral resources in Australia because we have a large number of resources that we already can identify. But in Australia, about 65% of the rocks that contain critical minerals are covered by thin sequences of, we call them cover sequences. They're basically sand. And they make it really hard to explore through. Geologists are really good at finding critical minerals and other minerals in places where we can hit the rocks with a hammer. We're less good at finding it in places where they're covered by these cover sequences. And so projects like this are the things that allow us to see through that cover, see into the earth and understand how the earth evolves through time, and really will open up the opportunities for providing for this growing demand. Graham, I don't know if you wanted to add anything to that.
No, I think, Tim, you've really described it very well. And all I would add is just that understanding the big scale structures, concepts, tectonics, the framework gives us that ability to be able to think better about targeting, about resource sort of exploitation, exploration, because we have a responsibility for that for everyone and future generations. So we have these big targets, and of course those big targets are, at the moment look very difficult to achieve, but we have to think our way through it, because to solve our problems that we have globally, we have to do something in a very constructive way. So, this project, but largely everything that AuScope funds is not specifically about critical minerals, of course, but it provides framework for understanding of the Earth as a planet, as a series of resources, a series of chemistry, a series of physics. And so we're helping to define some of those issues. But it's a very good question. I think we don't have all the answers, but we certainly need to be able to address those questions that you've articulated, Vivek.
Thanks, Graham. I might ask the next one, Joe, because the next one's addressed to you.
Okay.
So from Anthony Schofield, there's a question maybe for Joe. This is a really interesting way of communicating so many different aspects of studying geology. Just wondering who you see as the main audiences and what kind of impacts you're trying to achieve with this work.
Thank you, Anthony. So I think the full audience is really the National Science Week audience, the Australian general public, who are ultimately the funder of this kind of work. And as we see so often, don't know nearly enough about what is happening in this space. So, but specifically to your question, who is that key audience segment within there? I would say our emerging scientists, students who are considering going into science, and in particular earth and geospatial science, and kind of helping them to understand the breadth of what geoscience entails. I think that the perception of geoscience is geology, it's very focused, you maybe picture something when you hear geology, but the breadth of it, this science is amazing, and it's something that inspires me in my job all the time when I hear about the breadth of science that AuScope's enabling around the country, and all of these amazing research stories that are coming through, related to minerals, related to groundwater discovery, related to sea level change, related to mapping old animals in history across geological continents. There's so much that you can do in earth science. And I think we have two sort of challenges in the pipeline of one's geoscience career that are blaringly obvious to us today. And that is that people aren't quite sure what geoscience is, and therefore are maybe choosing something else like environmental science or geography, or maybe not even science at all, and not really understanding that they're all so intertwined, and you can sift and weave between those sub-disciplines to find a space that you're really passionate about as a young student, as a undergraduate, and then maybe a researcher or working in industry for government departments or something. But the other part of the challenge, I think specifically for geophysics, is the availability to study that particular sub-discipline within geoscience within the universities. You may be aware that COVID caused quite a few cuts to university funding, including some to geoscience and in particular geophysics departments around the country. So if you want to do geophysics, you can definitely still do it, but you might have to move interstate. But the thing that we know is that there will be so much demand for those kinds of careers in the future. So we feel it's part of our job to kind of go, hello, we definitely need you over here. It's very specialist skills and very diversely applicable as well across the geosciences. So that's how I would answer that one. The impact we'd like to achieve with that work is, fix that pipeline in different segments. The next question comes from Ron Hackney, which is a question for you, Graham. It sounds like you approached AuScope with the idea for this comms/outreach initiative. Was there anything in particular that prompted the concept and the approach to AuScope? Did you/AuScope always have a plan for something like this, or was it more of a sudden idea?
Yeah, thanks, Ron. That's a terrific question. I'll answer it in perhaps a couple of ways. It's been something I've been pondering for a while, and a little bit is in the concept that when we make geophysical measurements, of course, there's a whole bunch of technology and there's a whole bunch of mathematics behind the modeling and the data processing stream. But ultimately, we're measuring remarkable things. So we're measuring, for example, with the seismic sensors, the sound of the ocean maybe hundreds of kilometers away and the swell pounding against the margins of Australia. And the fact that an instrument hundreds of kilometers away is still listening for that kind of signal is quite remarkable. I also, when I'm talking to students, and particularly high school students, about magnetotellurics, it's a weird and wonderful technique. And a single instrument can have sensitivity from near the surface down hundreds of kilometers, which is in itself quite remarkable. But the instruments are also listening for lightning strikes around the world. So lightning strikes are happening maybe 200 times a second, and sometimes in the Gulf of Mexico and Central Africa and Southeast Asia. But that signal's passing by us all the time. And so we're measuring a quite remarkable natural phenomena that gives us information about the Earth. And when I talk to, say, high school students and I talk to community groups, it's very interesting to describe the physical measurements we're making in terms of natural processes that we can understand and we can see and we can identify with. And I thought, to some extent, some of that language about what we measure and how we measure things is lost in the final outputs and the products. So the products are often on websites, they're downloadable files and data sets and all kinds of different outputs and products, but they're very specific, but they don't capture something about the wonder of the technique. So I've been pondering this for a while, and I think that it sort of crystallized out that in the Curnamona area, we're looking at ancient geology, we're looking at very great depths of the earth, we're using all these remarkable signal strengths, and yet for most people, that's never sort of apparent and not captured. So that was one of my motivations, and I approached the AuScope team about this and said, well, maybe there's a different way we can communicate some of the outputs other than just simply data sets and so on. The other angle, which I guess has sort of come up a little bit more recently, but has actually also been quite a motivator, is that things like the equipment we use also has a story. So, for example, almost all the magnetotelluric instruments we use, and we have used over the last decade in Australia, have been built in Ukraine from the Lviv Institute. So those instruments are built by people we know and we've interacted with, and we have, a relationship over perhaps many decades now. And of course, their story has changed. And so our relationship with them has also changed. And in this case, the electromagnetic and the magnetotelluric community have very much come around those scientists in the Lviv Institute. Fortunately, they're safe. They're in the western part of Ukraine, and so they're relatively unaffected, although obviously Lviv's had a certain amount of strikes on it. But the equipment we use is built by people, and those people also have a story. So part of the story of the experiment is also that the equipment has a genesis or a history, and has a relationship to people who work as scientists around the world. So I guess bringing all those different threads together, that's kind of what I was approaching AuScope over the last year, to think a little bit about how we might take those products, the outputs, the storylines behind the data sets, and just promote that in a slightly different way and engage a different community. So look, this is our first steps in this direction, and I think there's obviously more things we can do, but I think we've certainly made some good progress in trying to talk about how people work on these projects and how they interact and how they interpret the data, and it's different from everybody's experience. So I think I'd love to carry on with this kind of process, because I think there's a lot of scope to be able to take our science, which is often appears to be quite narrow and quite small and relatively inaccessible, and make it accessible. So thanks for the question, Ron. It's a really good question.
Thanks very much, Graham. I don't see any more questions in the chat, but I guess your comment then about, this is a first step, leads me to think of another question for Jo, and you'd think that I would have already asked her this, but since we're sharing office. But this really is just hot off the press, this work, and was only really just completed yesterday in many regards, and the fieldwork was only just done a few weeks ago. So I guess, Jo, drawing on this very recent experience for you, what do you think's next? This is an experimental sort of style for storytelling for AuScope. What would you like? How would you like to see it evolve?
Thank you, Tim. Like Graham, I would like to see it continue to thrive, really. I think these non-traditional styles of communicating in this very busy digital media age can really bring a little bit of delight and surprise and engage people in a different way. So yeah, I think Philomena and I are always scouring around to see who's doing what, where, what kinds of interesting things could we potentially do in the future to bring that element of surprise. AuScope runs 8 programs in total and a number of pilot projects. So there is certainly scope for us to move this style of project to showcase some of our other projects over time, but also to expand in the Earth imaging project that we're showcasing here. I hope that this demonstrates to people that you can do things in a really short period of time with a cross-disciplinary team with a little bit of passion. You know, it's not just up to our marketing and communications department here at AuScope to do these things. We can all do these things as scientists in any creative way, I believe. It doesn't have to be polished, it just has to be well considered, I think. But yes, showcasing some of the other projects would be great. Engaging with new audiences in new ways, more participatory projects. I think it would be great if we can have a longer period of planning so that we can engage with people in the communities that we're working with. Yeah, just to kind of, particularly these remote places that might not have the opportunities to learn in these kinds of ways. Philomena and I believe that everybody can bring creativity to any project. So that's very inspiring for us to work with students, with scientists, with whoever, to bring a creative idea to life. Just by way of example, last year we collaborated with AIM, which is the Indigenous Youth Mentoring Organisation, to present a geoscience quiz for students at the Adelaide Botanics High School. That was aired globally, so people check that out all over the place, and the students answered all of the questions perfectly, which was quite fun. But we're looking forward to building on that piece of work next year together with AIM. Very recently, just this week, we've been working with the NCRIS network to produce a short video series that explains what AuScope and all of our 26 peer organisations funded under the same scheme, the NCRIS scheme, do, and presented by different people in each of those organisations. So that was a lot of fun, and you can find that out there on Twitter now. It's just a linked tweet of 27 videos. That's been quite fun to do. So I think it would be fun to expand the national public audiences, connect them in with our NCRIS network, because basically any piece of science you see on the television these days has some NCRIS facility sitting behind it. And we're all interconnected, and we connect across the sciences, you know, AuScope with Turn, with IMOS, the supercomputers, all sorts of other organizations. So we've got a lot to give, I think. What else can I tell you? Coming up, something to keep an eye out for. We're excited about this. We're supporting it by way of communications in the background, but there is a festival called Earth Futures Festival, run by Dr. Heather Handley, that aims to bring geoscience, promote geoscience for our sustainable future with audiences globally. So very soon, in the next month, we'll see that airing around the world. I believe there are 10 feature films that have been shortlisted already that we'll find out about in the coming weeks. So that's something to keep an eye out. I'll put all of these links in the chat in a minute. But yeah, we're very open to ideas. Please surprise us, reach out and suggest something to us. We are very open to collaborating with these kinds of projects in the future.
Thanks very much, Jo. We do have a couple more questions from the floor. So we've got a technical question for Graham. One of the researchers on the website mentioned how much the local environment had changed in only a couple of weeks in the region due to a significant rainfall event. Does the local climate variability affect the quality of the data acquired through the MT campaigns?
Yeah, thanks, Rebecca. It's a very good question. In a nutshell, it doesn't make a big difference to the data as such, in the sense that our signal is sort of global and interacts with sort of all of the Earth rather than perhaps the near surface. We are interacting with the near surface, of course, because our instruments sit on the near surface, but the data probably don't change very much. What does make a difference, though, obviously, is aspects of access and collaboration and communication with landholders, that we're very mindful of being on their land and working with traditional owners and farmers, and really sort of interacting in a way that it is not doesn't have impact, and so obviously we don't drive along really muddy roads, for example. A lot of our deployments across the region of the Curnamona is by helicopter, and largely that's because the I guess both aspects of time, access and impact are minimized using a helicopter. So it's a really good question. It has a little bit of impact, I guess, in terms of the logistics, but not specifically in terms of the data itself.
Thanks, Graham. And I guess the last question that's come in from Anthony is, he said promoting the use of deep earth imaging, new methods for assessing fertility for mineral systems to the mineral exploration industry can be a challenge. And so he's curious on how we think more creative approaches such as this can effectively get the message out and help with the uptake of new data and ideas. And I might actually throw this to Erin, if you don't mind, Erin, because you're, relatively new to this space and you're coming in sort of with a different view to those who are a bit more embedded in it. So maybe, do you have any thoughts on how this sort of creative way of delivering this can engage people better?
Yeah, I mean, an opinion, not really
Yeah,
ideas, but I think, like Joe was saying earlier, getting this point out to students, to future students, is probably really important, and just showing people what can be done and what is being done, and showing them, what is involved in fieldwork. Like Joe said earlier, and everyone I've spoken to really enjoys fieldwork. It can just be that game changer for a lot of people. I certainly do. So yeah, I think showing future students what is involved and getting that kind of interest, sort of peaked in more people. I think that is really important, and probably as early as you can do it as possible. For a lot of people that are trying to make their minds up, just about to go into uni or in uni already, it's really important. But certainly school kids, getting that interest into them early is really valuable.
Yeah, and such a huge challenge for our whole community, isn't it, to demystify what we do and to let people understand how exciting it is. And many people, obviously, there are a lot of names I recognize on this call. Many of us are geoscientists, and I'm sure we all have a different story to tell about how we became fascinated by geology. But Joe and I were reflecting earlier, and it seems like everybody has a story that at some point involves going out in the field, and that's what drew a lot of people in. So I hope that this sort of collaborative, creative approach gets that message across to people who maybe don't really know what it is we do. So look, we're really rapidly approaching 1 o'clock. And there's no more questions. So we'll start to wrap it up. If you do have a question that hasn't been answered, or that you want to reach out to us independently and follow up on anything, then please do. Joe's email address is in the chat, so grab that and have a look at it. And I'd like to thank you all for joining us today. Just while I close, I'm just going to share my screen because I can't miss this opportunity to talk a little tiny bit more about what AuScope is, given that that's my job. So look, I've put up a bit of an infographic here, which kind of summarizes what AuScope's about, right? Like this is a part of our sort of scope of work. So we have these earth imaging projects, which allow us to understand or to image what's beneath the earth and understand how the earth evolved and earth processes. And they're, as we said, relevant to things like mineral discovery, but they're also relevant to groundwater. They're relevant to understanding how the earth responds to the ice sheets melting, to the sea level rising. So these are all really critical pieces of information for us to predict how our planet's going to behave in the future, and how those things are going to affect society and habitability and all sorts of things. So they're critical parts of these Earth system models. But that's a small part. We also we have monitoring systems in place that allow us to understand geohazards, so risk of associated with earthquake events and various other geohazards. We have laboratories that allow us to understand the age of rocks and tell us about the history of our continent. We provide imaging facilities to allow people to understand what's in rocks, to characterize what's in rocks and the history again of those rocks, and to tell us about mineral deposits and things like that. We have outreach programs, which have been mentioned before. So we use seismometers to help engage with school students. So we have seismometers around a large number of schools in Australia, and we teach them about what geoscience is and what seismology is. We have a geospatial program, which has very long baseline interferometry telescopes, which sound very fancy, but they're radio telescopes that face at quasars, and then they allow us to work out where the Australian continent sits on the Earth using an extraterrestrial reference frame, which is really important. Every time you use your mobile phone to locate yourself, it's using data that's coming from these systems, because we need to be able to understand where we are really precisely now. We've got, you know, people like Elon Musk making cars that drive themselves around, and if the plate underneath them is moving, then we want them to know where they are on it, not just sort of drift to the south by 7 centimeters a year as our plate drifts to the north. So, you know, these dynamic reference frames that Geoscience Australia develops are part of that story as well. So we have all of that, but then we have all of this data as well. And so we manage that data and we deliver that data in ways that researchers and scientists can access it and use it. So that kind of is what we do. And we're going to hopefully continue to tell stories in novel ways so that you get a sense of what geoscience is, what AuScope is, and what our partners like Geoscience Australia and CSIRO and most of the universities around Australia provide into that narrative. So I guess I'll finish by thanking all of the members of this team. I can't thank you all enough, Graham, for coming up with the idea, Joe and Philomena for jumping on board with such enthusiasm and rushing out into the field and making the most of the time you had there. Erin, for giving your perspective on this, which is, you know, so important to understand the next generation of geoscientists and what you're thinking and how we need to serve the needs of the next generation as well. So thank you all for being involved. Thank you everybody who's dialed in today and listened into the story, because, you know, it is a new thing for us. We didn't know how it was going to go. And just seeing the number of people that have dialed in and stayed for the whole hour is really fantastic. So please share the site with your colleagues. If it is something new and you think it's valuable, we'd love to see more traffic to it, because that's how we can start to measure its impact. So yeah, and if you have any ideas about things that we could do in the future, different ways we can tell stories, and I'm sure Jo and her team would be really, really excited to hear them. So I guess we'll leave it there. Thank you all for joining us, and we'll see you all next time.
Thank you.